Hello to all of you audiences who are interested in learning Python programming language. Thank you for watching another tutorial video of Python programming language. Okay, now let's define a standard class, which special functions are defined as methods. This does not mean that what we have written so far is wrong. What we have written here, for example, these are not wrong. But this coding style does not have a very standard structure. Let's have a more standard one actually. Time. Define its methods, print, time. Don't forget to put the keyword self. Don't forget to put the colon sign. Okay, now we have a print time function here. We can exactly copy paste these in here. Okay, but all the t's need to be self, because here interpreter knows self, not these t's. You can see that the errors, the warnings were removed. Okay. Another method, a def. Let's have the increment method too. Don't forget to put the self and another argument, which was a seconds. If you remember from the previous video, let's find the increment method here. Increment function actually here. Okay, actually we need these for increment. We need to do these things here. We can have just two line of codes by doing such thing. Self dot time to int, and then we can come and return self dot int to time and seconds. Don't forget these selves, because in the classes everything is happened on a self. Now let's define this time to int and int to time functions. Again, the input argument should be self. We had such function here, time to int. We can copy paste all of these here, but don't forget to replace every time with the keyword self. This should be self and this should be self too, and you can see that all of the errors are wiped out. Okay, now we need to another method here, def into time, again self, and this time we need an extra input argument, which is seconds. Again, we can benefit from copy paste. This time Again, we need to substitute time with self. Self. And here we need this self too. Okay, in the process of converting functions outside the class to the methods inside the class, this increment function becomes a pure function. Now that we can convert time to integers and integers to time, it is easier to do such things here. Okay, let's run it. Let's press F5 and run it. Here, let's create the time object again. Here, time is the object of time. Again, we need time dot hour. We should initialize its values. Minute, for example, consider 20. And the second, consider it, for example, 5. Okay, now we can apply increment method on it with the input argument, for example, 3000 and 600. Let's press enter and we can see the result here. Actually, if we want to see the more visible output, we can use the print time method, which is defined here. But this time 1 hour was added to the value of this time. The hour was 10. When we run this line of command, now the asset, the state actually of the attribute hour in the time object is 11. Okay, now let's apply to this print time, which is a defined method here, and you can see the result here. Okay, actually this is the same self. In fact, you can see that when you want to write functions as methods, it is very easy, and the code will have a better structure. It is enough to be aware of self and where to put it. It is not difficult if you understand the concept well. If a variable is to be defined that applies to the entire class, this is the variable that should be replaced by self, which was time here. In some cases, it is necessary to create two objects. If we are going to have two objects of the class in the methods, the first one is always self. It is customary to consider the latter as other. For example, if we want to know between two time which one is later, we can have a method here, for example, name later, self, and other. This is just customary. Return self dot time to end greater than other dot time to end. The method works in such a way that it wants to answer the question whether self is later than other or not. Let's press F5 again, and we have a time object. Let's apply print time method on it. We can see the result here. Let's have another object. Time 2, which is an object of time. Let me consider its hour attribute as 16. Let me consider its minute attribute as 48. Let me consider its second attribute as, for example, 59. Now let's benefit from this method which we recently defined. We can use it like this. Okay, we got an attribute error. We can reset the kernel. Sometimes these errors may occur. Don't be worried. After the restarting process finished, we can again press F5 and in this way run this file again, and again define time variables and time 2 variables. Actually, time and time 2 are objects of a time class. We can again do the process and go through it, and you can see the result. You can see that this later method will be working as same as the other methods here. Okay, let's press F5. Let's have time as a class, as an object of class time. Let's have our attribute as, for example, 12. Let's have the minute attribute as, for example, 10. Let's have its second attribute as, for example, 5. Now let's print it. At first let's define another object from the time class. Let's have the attribute hour with the state, for example, 16. Let's have its minute attribute with the state 48. Let's have its second attribute, for example, with the state of 55. Let's print them one by one to see these are working correctly. This is time, and let's see the time 2, and you can see, and these are time. This is time 1, this is time actually, and this is time 2. Now let's apply the later function on time 2, and you can see this is false because time is not greater than time 2. So you can see that the later method is working correctly. In this way, where we're going to use two objects, it is customary to use other word, which I said before. Pay attention that other is not a keyword because it is not defined like a self in Python. You can see that there is no color change. It is just one of thousands of arguments among Python programmers to use this word in these situations. Other is just one of the conventions of Python, and it is suggested that you also follow these conventions. Let's go for the magic methods. You know that with the help of init actually magic method, we can get free from these kind of initializations. So let's do it. Let's define def init. Don't forget to put self, and now our attributes over ours. I want to consider the 0 as its default value. The other attribute is mainnet, and the other one is a second. Okay, don't forget to put the columns. Let's consider self.hour is hour, self.minute is minute, and self.second is the same, second. Okay, that's good. Let's press F5. Now here let's have, for example T4. Hello. Let's have T0 as an object of class time. Let's do not enter any input argument here, and you can see it here. We can actually print it and see the result. You can see these are 0, which are defined here. Let's have T1 time, but this time input argument, for example 2 4 55. Now let's apply print time. You can see the result here. If the input of this time class is only one argument, it works positionally and assigns this number to the first attribute, which is the hour. Let's try it. T2 as an object of time, for example, just 5. Now let's apply print time on it, and you can see the result. Okay. We can also have T3 time, this time 2 input argument, and then print it, and you can see that these are assigned positionally. Okay, so you can see how much better it can be to work with this method. Let's rewrite the built-in print function itself. There is a magic method called str. For this purpose, we can have it here. For example, I previously told you that it's better to consider the magic methods before the other methods in the class. So let's put it here, str. You can see that Python knows it. Don't forget to put self. We want to return something, and we can use the same phrase here. We can copy paste it. actually these are not necessary. Okay, you can see that there is no warning or error. Okay, we can press F5. Let's now apply print on this T3. Okay, when we make a change in this step on the class, this change is not applied to the objects in the class, but new objects created from this class will include these changes. For example, if we have a T4 as an object of time and with the values, for example 9, 42 and 36, for example, if we apply this print function on them, we can see that this is working correctly. Another thing that can be done is rewriting operators. Well, we mentioned it briefly in previous videos. We can see it here. Okay. For example, to rewrite the addition operation, we can act in this way. You can see here there is add magic method here. Def this way, add self and other, as we talked about it. Let's have a second variable, which is self dot time to int plus other dot again time to int. Then return self dot int to time with the input argument this second which we calculated here. Okay, let's press F5, run it again. Let's have a start object from this time and class, which its hours attribute has the 11 state, its minute has the 29 state, and its second we consider it's 0 here. Okay, let's have the duration as another object of time class with the states 1, 45 and 17. Let's have print, for example, start plus duration. You can see that this is working correctly. Add has a definition in the interpreter that may not match the type you use in the program. In these cases, you can perform these rewrites. As an exercise, you can rewrite the equality operator. So that if the hours, minutes and seconds are equal, it will return the correct one, and otherwise it will return actually true statement, and otherwise it will return false. Now if we want to add a number to time with the same addition operator, we should do it like this. We should have something like this here. If is instance, you got familiar with this built-in function recently. Other class time. Okay. If this condition is true, we have a time increase here. Okay. If this condition is true, let's comment these in this time. Right click and comment. Okay. If this is true, do, for example, return self dot time increase on other. Else return self dot increment on the same other. You can remember that this increment had the seconds as input arguments, which was a number, which was integer numbers in seconds actually. Okay, now there is a problem here. Time is instance time. Actually, this is a class. Okay, but now we need to define time increase class 2. Let's have def time increase. Don't forget the self as an input argument, and that the other one, it is better to be other. Okay, we had the time increase function here. We can actually copy paste let me check. Okay, no problem. This is time. But you know that you need to do it on self. Actually, this is not we do not need these lines of codes. Actually, we do not need them. We can remove them. Here we need to actually do this self, and instead of T2 we need other here. Here we need another self. Okay, you can see that there are no warning or errors. Press F5 again. Okay, we can see something like this. Let's have, for example, T5 time to 3556 T6 time 32445 print T5 plus T6, and you can see that it is working correctly. We can try T5 plus, for example, 2400. You can see that this is working correctly again. And now how about print, for example, 3600 plus the same start. You can see that there is an error. We get an error. To fix this flaw, we need another magic method, which is our add. You can see here right side add. We can add it here. Def our add. Actually we need self and other. Don't forget to put colon. Return self dot add other. Okay, let's press F5. Right side add is related to when the object is put in the right side of the add operation. Another important issue is polymorphism. Let's see an example. Print the same T5 plus 3000. You can see the result. Now print 3000 plus the same T5, and you can see, okay, again we got an error. This should be not like that. Again we want to restart the kernel, and again we here press the F5 button. Again we are waiting for this restarting. Okay, does it run? F5, another F5. Okay, now T0 time 2:11:25. Let's have print this T0 plus 200, for example. Again print 200 plus this T0, and you can see that this is working correctly. Okay. Another important excuse me, another important issue is polymorphism, which is a very simple concept. Let's have a new file. Def, let's define function print, for example, everything. It has an input argument, print str, this argument. Let's run it. and we can do, for example, print everything. We can apply it on an integer. We can see the result. We can apply it on a string, for example, hello. We can see the result. We can apply it on a list. We can see the result. We can apply it on a set. We can see the result. Okay, I forgot to put a curly brace here. Okay, we can see the result. We can apply it on a tuple, for example, 2, 4, 6, 8. We can see the result. We can apply it on a dictionary, for example, 1A, 2B, 3C, and we can see it's working. We give any type as input to this function, it will print its string format. They say that this function is a polymorphic, that is, it supports polymorphism. A polymorphism comes from here that any type of input we give it, it does its job without error. Supporting this polymorphism can make a code reuse much easier. Well, there is something like this in Python because the interpreter does not check types, does not actually type checking. If it is possible, it performs operations on the inputs, and if it is not possible, it gives an error. For example, as long as the input arguments of the sum function support the addition operation, it will do its job. Our time class objects support this operation. For example, if we have, for example, T7, object of a time class, for example, 3, 10, 28. If we have the T8 as object of time class 9, for example, 51 and 2. If we define T9 as object of a time class, for example, 40, 50, 15, 44, and we can define a T as a output of sum on the list of these 3 objects. We can see that this is working. This is okay. This is all working correctly. We can print T, and you can see the result. So you can see that this feature of polymorphism exists inside Python. That's why we got the correct output here, even though we didn't define the sum method. You have to be careful that sometimes this polymorphism can ruin the work. You can prevent these potential errors with annotations. The next issue is inheritance, which has meaning in object-oriented programming. You create a class which we will call this class parent class or base class, and then you create a series of other classes which we call child classes. You can have different child classes. These child classes inherit from the parent class. This inheritance means that the child classes can have the characteristics and the methods of the parent class. If we want, we can rewrite some of these features or methods in each child class, and again these child classes can each have their own child classes. These new children can inherit from their parents. We can restart the kernel again and open a new file. Let's have, for example, class person. Let's do initialization here. Don't forget to put the self. In addition to that, we want to have other attributes like a first name and last name. Okay, now we want to tell it self dot first name would be the same first name, and self dot last name would be this last name. Okay, this is a class, you know. Now we can consider some methods in it. For example, print name, self, print, for example, self dot first name and self dot last name. Okay, press F5 here. We want to have A as an object of this person class. Input arguments Ghazal and Lalu Ha. Okay, now apply print name. Now we want to create another class. For example, we want to say that this person is a data scientist. Let's have another class here. Class data scientist. Here we need to mention the parent person. Actually, we do not need these input arguments here. Okay. For this time, let's consider paths here. Let's press F5. Let's have B as an object of this data scientist class. We can give it the same input arguments to it. Lalu Ha, actually. Okay, you can see that we can apply print name on it, and it is printed. B is an object of the data scientist class that inherits the initialization from the person class. You can see that it also inherits from the print method. Now you can develop this child class yourself. For example, instead of this path, we can consider another initialization, for example. Self, first name, and last name, and we can consider person, dot initial self, first name and last name. Okay, when you write the init method in the child class, this class no longer inherits from the init method of the parent class. For this purpose, you can use the super built-in function to you can of course we did it with this phrase actually. Okay, this is one way. We can also use another form. For example, we can have super built-in function and put a dot init method. You can see first name and last name. In this way, we can add a feature to this class too. We can have, for example, self.experience as a experience itself. Okay. Experience. Let's consider it, for example, her experience. Do not any fault here. This could be her experience. This could be experience. Okay. In order for the class to have a better structure and the calls to be easier, we can add this feature to the arguments in the definition of the initial function. For example, here we can have experience too. For example, here her experience. Here we can do this too. No difference between them actually. Actually, there is no need to this here. Okay. When we use super, we don't need self anymore. Let's have another print here. For example, def print data scientist. Of course, we need a self again. We use print self, first name, last name, and again the experience. Okay. Let's press F5. No arguments, super. Okay, okay, okay. Okay. Instead of super, let's have this previous form. Let's super. Def. Maybe I didn't. I shouldn't do that. Consider experience here. Experience here. And here semicolon, indentation, okay, okay. What is first name, last name, and experience? What is first name? Actually, all of this should be self dot first name, self dot last name, and self dot experience actually. Okay, let's press F5 and we can see, for example, we had B. Let's have C as object of data scientist with input argument, for example, Sayed. Let's another name, for example, Faiza. Salehi, for example, senior. Text 2 positional. Now we did it 4. Okay, we can add this experience to okay, now print. See, we didn't consider that. Okay, this is the default output of a print function. We didn't rewrite it in this class. We should use this print, this defined method here, data scientist, and we need to apply it on this C. Actually, as we consider the self, this shows us this part 2. Let's press F5 again and again. Use the command. Let's restart the kernel. Let's wait to kernel become completely restarted, and then again press F5 and define the same C as the object of this data scientist class with the input arguments Faiza, Salehi, senior, level, C dot this print data scientist. Okay, we can see that the ECRD problem was solved here. Actually, we can use this print name on the same object because this data scientist class is the child class of this person class. You can see that it is working well too. You can see that developing the child class is not the slightest different from developing the parent class. Okay, you can see that how in this video we learned to have a more structured classes. Okay, thank you so much for watching another tutorial videos of Python programming language. Stay tuned because very useful and delicate notations and points are awaiting for you in the upcoming videos. Stay tuned. Have a nice day.